Hello friends, in today's class we are going to talk about priority based scheduling. So welcome here, and we are talking about priority based scheduling. And the SJF, shortest job first algorithm, is a special case of general priority scheduling algorithm. A priority is associated with each process, and CPUs allocated to the process with the highest priority. Equal priority process can be scheduled in FCFS order. So we are associating a priority to each process, and allocation of the CPU will be based on this priority. And if you have an equal priority, then in that case it will be in FCFS, first come first serve order. Now you talk about SJF, shortest job first. Okay, now here in that case we can say the priority is inversely proportional. We can say the more burst time, right? If the higher the burst time, right, higher the burst time, then the lower the priority, because shortest job will be preferred first. Okay, so they are the priority is inversely proportional to this its burst time. And SJF is a simple priority algorithm where priority is the inverse of the next CPU burst. The larger the CPU burst, the lower the priority, or vice versa. Okay, so that's why SJF algorithm is taken here an example, and we have already seen a lot of example for SJF. Priority based scheduling, first mode we are learning here, I'm implementing here is a non-preemptive, and once we are done with the non-preemption, then we'll come to the preemptive version of it. Okay, we'll come to the preemptive version of it. Okay, so let's go and first implement this this non-preemptive version. Priority can be a static that do not change throughout the execution, and it may be dynamic where priority may change. Okay, now here one advantages can be there, and we are like suppose a process is long time is a lower priority process. Okay, lower priority process, and because of that it is not getting executed. Always what happens is a higher priority process comes in the queue and that get executed, and the lower priority process is starving for what? Starving for the resource. Okay, so in that case we can use an algorithm that is called an aging algorithm, that priority over the period of the time, priority will be keep on increasing of that process, so that finally it will get the chance for the execution. So I hope I'm clear over here. Now this is the example of non-preemptive priority based scheduling, and here we are having the priority, and the higher the integer, higher the priority, right? So the higher integer is having higher priority, and we have 6 process, 1 2 3 4 5 6. We have a priority as 4 5 6 8 2 12. Arrival time is 0 1 2 3 4 5. Burst time is 4 5 8 6 3 5. Okay, so let's prepare the Gantt chart, that how exactly this will be scheduled. So let's have a Gantt chart for this. And since it is a non-preemptive, we have to only consider at the given moment that which algorithm is having the highest priority. Okay, so this is my Gantt chart that I'm going to put. So at 0 instance, we have only one process which is having a priority of 4, but no one has arrived till now, so we have to go with this P1, and I can't preempt it, so this will go throughout this 4. Now up to 4, you see that we have arrived a process with the different priority 5, 6, 8 and 2. 5, 6, 8 and 2. And among this 8, which is P4, is the highest priority. So let me write here P4, that is having highest priority, and its burst time is 6. Right? So P4 will be scheduled, and in this case this will be up to 10. Now everything is there, and what we have done here, let me just mark it out here that some way. So we are done with this, and we have done with this 8 part. We have done this both part. Now we are left with the 5, 6, 2 and 12. As at the 10 instance, every process has already been arrived, and 5, 6, 2 and 12, the process is having highest priority is your process 6, and we are going to schedule P6, which is having burst time of 5, so that will go up to 10 to 15. So now we are done with this part also. Let me put in a circle. Now we are left with 5, 6 and 2, and P3 is the highest priority in this case. P3 is having highest priority and its burst time is 8, so that will become 23. So now we are done with this P3 also. Now we are left with 5 and 2, and in this 5 is having the highest priority with the burst time 5 and process is P2. So in this case I will write 5 and that will go for 28. And finally we will go with the process P5, which is having a priority of what? Priority of 2, the lowest, and burst time of 3, and that will become 31. So now this is the Gantt chart for this the non-preemptive model, and more or less this is easy to implement. Non-preemptive models are easier to implement because we don't need to keep track how much time is remaining. Let's have a look at the preemptive model of it and also keep track that how much consumption of the actual burst time has been done. Okay, in preemptive model that is important, and we have to be careful with this consumption. Now consumption means, don't confuse with this, the amount of allocated time in CPU, that is the consumption. So at instance 0, only one process with priority 4 is there, P1. I'll schedule it for, let's say, this. The moment at time 1 another process arrived, let's say P2, and it is having a higher priority, so we will preempt it and we'll schedule P2. At 1 something changes. At 2, let's say at 2 another process is coming with the higher priority, that is 6. So immediately we'll turn to P3, 1 time unit. At the 3 time unit, another process is coming with a higher priority, that is 8, and which is P4. And that at 4. At 4 you see a process is coming with the lower priority, which is only 2. So we'll continue our execution with P4. At 5 we are having another process with the priority of 12. So now we'll schedule what here in this case is P6. And how long will continue? Okay, now up to here, because every process has arrived, thus now there will be no preemption. Now up to here P1 has consumed 1 instance, so now we are left with only 3 burst time. P2 is 1, so we are left with only 4 burst time. P3 is 1, we are left with 7 burst time, and P4 consumed 2 times, so we are left with only 4 burst time. This must be noticed, and it should be keep track that how much burst time is remaining. Now here is your P6, and we are scheduling at 5. P6 required the burst time of 5, so P6 will schedule up to 10. Now it is done. P6 is done. Among 4, 5, 6, 8 and 2, 8 is the highest priority, which is P4. But notice that for P4 we have already executed 2 instances, only 2 instances remaining. That will make it 14. So now we are done with P6 and P4. Let me just, P6 we are done and P4 we are done. Now among 4, 5, 6 and 2, the highest priority is P3, and that is 6. P3, and that is 6, and that will make it 20, right? P3 is P3 is having 7, and that will make it 21. 7, and that will make it 21. Okay, so that is 21. And then after, so now we are done with P3 also. So let me just put a circle over here. Now we are having 4, 5 and 2. So 5 is the highest priority, which is P2, and which P2 is left with the burst time 4, which will make it 25. Now we are left with 4 and 2. Definitely we'll go with 4, and the burst time here in this case is only 3, and that P1 with the burst time 3, and that will be 28. Last one is your 2, and that is having burst time of 3, and that is your P5. That's 31. Fine. So this is the Gantt chart for this preemptive one. And I hope you will agree with this. Okay, so this is the Gantt chart for the preemptive scheduling, where higher integer is having higher priority. So this is the Gantt chart for preemptive and non-preemptive priority. Both we have already seen. Problem, I already mentioned you that there is some issues with the priority scheduling, and which is the major problem with this priority scheduling is indefinite blocking or starvation. Okay, so there is a starvation. A process that is in the ready to run is waiting for the CPU, but considered blocked because of a lower priority, right? So a priority scheduling can leave some low priority job, and process may be waiting indefinitely. That is one issue with priority, and I already told you what to do. Solution is the aging. Aging is the process by which we will be keep on increasing the priority of a process. So a solution to the problem of indefinite blockage of low priority process is aging. Aging is a technique that gradually increases the priority of the process that will wait in the system for the long time. Correct? So that is your aging, and that is the solution. I leave you with one homework problem where you can go for drawing the Gantt chart. Okay, and the Gantt chart should be designed or for the model one, that is preemptive one, as well as you have to design this model from the non-preemptive one. Right? So design both the model as preemptive and as non-preemptive. So that's all for this discussion of priority scheduling algorithm. Thank you.